I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of Image Processing. In this session, we will discuss about distance measures, linear and nonlinear operations. So, especially in distance measures, there are different types, there are different methods to measure the distance. One is Euclidean distance, 4 distance, which is also called as city block distance, and another method is 8 distance, and another name for this 8 distance is chessboard distance. So all these 3 methods we are going to discuss, and these 3 methods are used to measure the distance between pixels. And the next important topic is linear and nonlinear operations. Now, so to measure the distance between pixels, in this, here we are going to consider one example which is having 3 pixels P, Q and Z, and each pixel is having their own coordinates, and the coordinates related to these 3 pixels are XY, ST and VW. So it means here one pixel is P, another pixel is Q and another pixel is Z. So the coordinates related to the pixel P are X and Y. So the coordinates related to this Q pixel are S and T. The coordinates related to the pixel Z are V and W. So let us consider these 3 pixels with their respective coordinates, and we will see how to measure the distance. So for example, here let us consider there are different conditions and the distance between any 2 pixels may be any value. For example, in this first case, if we see d of P comma Q, it means distance between the 2 pixels P and Q may be greater than or equal to 0. So for example, if we consider here all these are the pixels, if we consider all these are the pixels, and if you consider this is the pixel P and this is the pixel P and this is the pixel Q. If you want to measure the distance between this P and Q, so this is the distance between P and Q. The distance between these 2 pixels will be greater than or equal to 0. Any value it will be. In another case, the distance between this P and Q will be equal to 0. So when the distance between this P and Q will be equal to 0, if P is equal to Q. So if P is equal to Q, that means if both the pixels are same, then the distance between the 2 pixels will be equal to 0. So if the pixel P and Q are same, the distance between the 2 pixels will be equal to 0. Now, in the second case, the distance between P and Q pixels should be equal to the distance between from Q to P. So, for example, if we consider these are the pixels, and if this is considered as a pixel P and this is considered as a pixel Q, here this is the distance between pixels P and Q. That means whatever the distance is from P to Q, the same distance should be there from Q to P. So distance between P and Q pixels should be equal to the distance between Q and P. That means whatever the distance is here, the same distance should be from Q to P also. That means if the distance from P to Q is 2, the distance from Q to P also should be 2 only. So coming to the third case, so the distance between the pixels P and Z should be equal to sum of the distance between PQ and QZ. It means here, for example, if we consider these are all the pixels, okay, and if you consider this is pixel P, here 3 pixels are considered. One is P, Q and Z. So consider this is P and this is Q and this is Z. So here the distance from P to Z. So this is the distance from P to Z. This is the distance from P to Z. And here this is the distance from P to Q. And this is the distance from Q to Z. Okay. So here the distance from P to Z should be equal to the distance from P to Q plus the distance from Q to Z. It means, for example, if the distance between P to Z is 5, so the distance from P to Q is 2 and Q to Z will be 3. So here it becomes 5 is equal to 2 plus 3. So this is the third case. So any of these configurations may be used in order to calculate the distance between pixels. Now, so here there are different methods to measure the distance between pixels. One is Euclidean distance, another one is Ford distance, which is also called as city block distance, and the next method is 8 distance, which is also called as chessboard distance. So we will see each of these methods in detail. So ultimately these 3 methods are used to calculate the distance between pixels. So coming to the first method is Euclidean distance. So here P and Q are the 2 pixels as we have considered in the previous example. Here P and Q are the 2 pixels they have taken, and the coordinates, as we have considered earlier, the coordinates of P will be X and Y and Q will be S and T. So considering these 2 pixels, in order to find the distance by using this Euclidean distance formula, here the formula is here DE, the small e we can see here. This E represents Euclidean between the 2 pixels P and Q. So in order to find the distance between these 2 pixels P and Q using Euclidean distance formula, the formula is here root of x minus s whole square plus y minus t whole square. So here it is written as whole power 1 by 2. You can also write this as root of x minus s whole square plus y minus t whole square. So here the values of x, s, y and t we will be having because they are the coordinate values of the 2 pixels P and Q. So by using this formula, we can calculate the distance between the 2 pixels P and Q. So this is one of the method. And second method is by using this 4 distance method. So this 4 distance method is also used to find the distance between pixels. Here also we have considered the 2 pixels P and Q. So here also we have considered the 2 pixels P and Q having the coordinates values X and Y, and here S and T. So this 4 distance measurement is also called as city block distance, and the formula to calculate the distance between 2 pixels using this 4 distance is, so this D4 of P comma Q, as we are measuring the distance between the 2 pixels P and Q, and it is the 4 distance measurement, it is represented as D4 of P comma Q is equal to modulus of X minus S plus modulus of Y minus T. And here the values of X, S, Y and T we will be getting from the coordinate values of the 2 pixels P and Q. And so if we consider here one example, and we will see how to measure the distance between 2 pixels by using this 4 distance. Now, when we can say the pixel Q is 4 adjacent to P means, so if we consider here this is P and this is the pixel Q, how to measure the distance between these two by using 4 distance means. So let us consider the distance between each pixel is a unit distance. So when we say that this Q is 4 distance of P means, here there is one condition. So Q is 4 distance of P if Q lies among 4 neighbors of P. So considering this pixel as P, the 4 neighbors of P are, this is one neighbor, this is one neighbor, another neighbor, and this is another neighbor. So here we have considered the pixel Q, and this Q is one of the neighbor of P. So we will say that Q is 4 distance of P. Now, so the value of Q is equal to 1 when the distance between P and Q is 1. So as we have considered in this example, the distance between 2 pixels is a unit distance, that is 1. So here the distance between this P and Q, or the distance from Q to P, will be 1 if Q is equal to 1. When this Q is equal to 2, if the distance between P and Q is equal to 2. So here, if the distance between P and Q is equal to 2, then the value of Q will be equal to 2. That means, maybe if this is the value of Q, you will have here one more unit distance. So this is 1 and this is 1. The distance from Q to P will be equal to 2. Then the value of Q will be 2. So as the value of Q is here 2, the distance from Q to P will be equal to 2. So this is how we have to measure the distance between 2 pixels P and Q by using 4 distance method. And another method to find the distance between 2 pixels is 8 distance. So this 8 distance is also called chessboard distance. So in this case also, we are going to consider the 2 pixels P and Q. So P is having the coordinates XY and Q is having the coordinates ST. And let us find the distance between these 2 pixels PQ by using this 8 distance method. So the formula for calculating the distance between this PQ using 8 distance method is, here we can see D8 of P comma Q. So this PQ represents the 2 pixels in which we are going to find the distance between them, and this 8 represents, it is the 8 distance measurement, and this D represents it is distance. So in order to find a distance measurement between the two pixels P and Q, the formula is max of mod of x minus s, comma mod of y minus t. So same formula will be there for distance measurement also. But here in 8 measurement distance, we are going to have one extra term which is max. Whereas in 4 distance measurement, we will not have this max term. Now, so let us consider an example and let us see how to find the distance between the two pixels PQ by using this 8 distance method. So this is the example we have considered. Let us consider here the center pixel as P, and here let us consider any other pixel which is at the neighbor of P as Q. So when we can say that Q is at 8 distance of P means, here we have one condition. So Q is 8 distance of P if Q lies among 8 neighbors of P. So here if we consider this as P, what are all the 8 neighbors of P? So this is one neighbor, another neighbor. So all these are the neighbors of P. So here 1, 2, 3, 4, 5, 6, 7, 8. Totally 8 neighbors are available for P, and Q is one of the neighbor of P. Then we can say that Q is 8 distance to P. Let us consider here the distance between each pixel is a unit distance. So when the value of Q will be equal to 1, if D8 of P comma Q is equal to 1, that means if Q here the value is 1, the neighbor value is 1, that's why Q will be 1 if D of P comma Q is equal to 1. So Q will be equal to 2 when D8 of P comma Q will be equal to 2. That means if you consider all these neighbors, the values, neighbor values are here 2. If you consider the pixel Q as any of these neighbors, then we say that Q is equal to 2 when D8 of P comma Q will be equal to 2. So it is based on the neighbor. So in the first case, Q is neighbor of P, Q value is 1. And in the second case, if we consider here Q is the neighbor of P, 8 neighbor of P, but here Q value is equal to 2. So these are the 3 methods in order to measure the distance between two pixels P and Q. So if you want to find by using this formula, the values of this x, y, s, t coordinates will be given. So these are the 3 methods. Now, another important thing we need to learn is shortest path distance. How to measure the shortest path between the pixels. So here, in order to measure the distance between two pixels, generally, 2 things need to be considered. One is the values of the pixels along the path, and another one is the values of their neighbors. So these are the 2 important things we need to consider when measuring the distance between two pixels. So here, let us consider an example, and in this example, see the way how all the pixels are arranged. So here there are different pixels. So we can see here P, and here P1, P2, P3 and P4. So all these are the pixels that are arranged in this manner, and here some of the pixel values are fixed and some of the pixel values can be variable. So for this structure, let us consider the pixel values of P, P2 and P4 are 1. That is, it is fixed. So here this is P, that means this pixel value is 1. And this is P2, its pixel value is 1. And another one is P4, its pixel value is also 1. And another condition, consider P1 and P3 can be the values of 0 or 1. That means here this is P1, this pixel value can be 0 or 1. And this is P3, its pixel value can be 0 or 1. So anyway, these 3 pixel values are fixed and these 2 pixel values are vary. So 0 or 1. So it means here P1, P, P2 and here P4, they are fixed and that value will be equal to 1, whereas P1 and P3 are variable, that values may be 0 or 1. So based on this condition, what we can understand, the pixel value can be, P1 can be 0 or P3 can be 0, or in other case P1 can be 0 or P3 can be 1. In next case, P1 is 1, P3 can be 0, or in the last case, P1 and P3 both can be 1s. So based on these conditions, we will see how to measure the shortest distance between the pixel P to P4, and by considering all these different cases. So as this is fixed, these are variable, we can have 4 cases. Let us consider this is case 1, 2, 3 and 4. Okay. So we will see in detail. Now, so in continuation with that, to measure the shortest path distance, we have considered the values of P, P2 and P4 pixels as 1, whereas P1 and P3 can be 0 or 1. So let us consider the first case, P1 is 0 and P3 is 0. That means here this P, P2 and P4 are 1, whereas P1 and P3 will be zeros. So this is how the pixels are arranged. So in order to measure the shortest distance, so here distance I am indicating the distance here with dotted lines. Let us consider here dotted lines are representing the path and the distance, and consider the distance between the 2 pixels is a unit distance, that is 1. So here from P1 to P2 and from P2 to P4. So this is the shortest distance. So the path is here P, P2, P4. This is the shortest path. And if we consider the distance between these two as a unit distance, okay, that means here distance between pixels. Distance between pixels consider as a unit distance. Then here in between these two, 1, in between these two, 1. So the distance is equal to 2. So this is how we have to measure the shortest path. And considering the next case, that means P1 1 and P3 0, only these will be varying, whereas here P, P2 and P4 are same, that is 1. So P, P2, P4 will be 1, whereas P3 and P1 will be changing. So here P1 is 1, P3 is 0. So in order to find the distance, here we can have different paths, like, so from P to P1, from P1 to P2 and from P2 to P3. This is one path. And Another path may be directly from P to P2 and from P2 to P4. So here there are two paths available. So here P to P1 is 4 adjacent, P1 to P2 is 4 adjacent, and P2 to P4 is 8 adjacent. This is one combination. And another combination is P to P2, which is 8 adjacent, and P2 to P4, which is 8 adjacent. So here two paths are available. This is one path and this is another path. This is 4 adjacent and this is 8 adjacent. P to P4 there is no way, so we have to consider it as a single way. And so in such cases, that means if we have two paths here, we have to consider 4 adjacent only and we should eliminate this 8 adjacent. So the path what we have to consider is, this. Okay. So that is P, P1, P2 and P4. So if we consider there is a unit distance between the two pixels, this is 1, 2 and this is 3. So the shortest path distance here is equal to 3. Now, the next case is case 3, whereas here P, P2 and P4 will be fixed, that is 1. So P, P2 and P4 is fixed, that is 1. And another one is P1 is 0 and P3 is 1. Okay. So in such case, to find the shortest distance, so it will be existing from P to P2 and we can have here P2 to P4. This is one way. From P to P4, this will be the one of the shortest distance. And what is another combination? Another combination is from P to P2 and from P2 to P4, P3 and from P3 to P4. This is one way of finding the shortest distance. But if we consider here, this represents the 4 adjacents. This is 8 adjacents, this is 4 adjacent and this is also 4 adjacent. But if you compare this path, this is 8 adjacent and this is also 8 adjacent from P to P4. So if there are many paths available like this, as I already told, we have to consider 4 adjacent only and we should not have here 8 adjacent. So this path should be eliminated and this is the path we have to consider. So because of this, the path now here will be P, P2, P3 and P4. So if we consider there is a unit distance between these pixels. So here it will be 1, 2 and this is 3. So the distance here will be equal to 3. Now coming to case 4, in case 4 also these pixel values are fixed, that is P1, P2 is 1 and P4 is 1, whereas here P1 and P3 values are also 1. So P1 is 1 and P3 is 1. So while drawing the shortest distance from P to P4, we have to consider the path which is 4 adjacent and we should not consider 8 adjacent unless there is no possibility. So here the way is from P to P1. P to P2 also we can draw, but it is 8 adjacent. We have already 4 adjacent possibilities, so consider that. And here from P1 to P2 and from P2 to P4 also we can draw, but this comes under 8 adjacent. As we have path considering 4 adjacent from P2 to P3, we should not consider 8. from P2 to P3 and P3 to P4. All these comes under 4 adjacent. So the shortest distance will be P, P1, P2, P3 and P4. So if we consider unit distance between these pixels, so this is 1, 2, 3 and 4. So total here the distance will be equal to 4. So these are the 4 conditions considering the example we have applied in order to calculate the shortest distance. So this is a topic about distance measures, and the next topic is about linear and non-linear operations. So when we say that the operator is a linear operator and when we say the operator is a non-linear operator means, so let us consider an image f of x comma y, and if you apply any operation on the image, so here consider this is h is the operator that we are going to perform on the image f of x comma y, then the output what we are getting will be again the image, but it is a modified image g of x comma y. That means the output what we got is g of x comma y after performing some operation on the input image f of x comma y. Okay. So this operation, how we can write here? H of x comma y. That means the operator applied on the input image f of x comma y is equal to the output image g of x comma y. So by applying the linearity principle, we can modify this equation by considering 2 input images. Here we have considered only one input image f of x comma y. So let us consider 2 input images, that is f1 of x comma y and f2 of x comma y, and let us apply the operation on the 2 images, then we will see how the output will be. Now, so considering h as a linear operator, h of a into f1 of x comma y, that is first image, plus b into f2 of x comma y. Here we can observe a and b, those two are the constants. This equation can be written by applying linearity principle. We can write this as a into, as we apply any transform, the value of constant will not change. So here a and b will be as it is. H of f1 of x comma y, h of f2 of x comma y. So if we apply any operation on image, it will be changed to g of x comma y, modified image we are going to get. So a into g1 of x comma y as it is f1, and if we apply any operator on the input image f2 of x comma y, we are going to get the modified image as g2 of x comma y. So here a and b are constants. And if you consider this equation as the right hand side equation and this as the left hand side equation, if the value of this RHS is equal to LHS, then we can say that the operator H is a linear operator. So this is what about linear operation. Coming to the next one, that is non-linear operation. So considering the same principle, that is here consider the image, input image f of x comma y, and if you apply any operation on that image, here the operator consider as h. If you apply any operation on that image f of x comma y, then the output image what we are getting is a modified image. So here in the previous case, we have considered the value of h as a linear operator. So in this case, consider the value of h as a maximum operator. So here h is considered as maximum. So according to linearity principle we have seen in the previous slide, we can write as a of considering 2 input images, that is f1 of x comma y and f2 of x comma y. It can be written as h of, that means you are going to apply maximum operator on the two input images, f1 of x comma y plus f2 of x comma y. Here a and b are constants. It will be modified as a into h of f1 of x comma y plus b into h of f2 of x comma y. Here constants will not be modified, even though if you apply the operator, they will be constant. So here they are taken out and written. So how it will be modified? As the value of h, the operator h what we have considered is the maximum operator. We can write this as max of, so in place of h, max is written. A into f1 of x comma y plus b into f2 of x comma y is equal to same. Here a, here h is replaced with a maximum operator as h is equal to max. f1 of x comma y plus b into max f2 of x comma y. So in order to clearly understand, consider here the two input images f1 and f2, and the values of this f1 consider 0, 2, 2, 3. Any values we can consider. And here f2 is the second image. Let us consider the values of this image are 6, 5, 4, 7. So here a and b are two constants. A is equal to 1 and b is equal to minus 1. So if you apply this operation on the two images, and let us see whether LHS is equal to RHS. If LHS is equal to RHS, then we can say that the operator H is a linear operator. If they are not equal, then H is a non-linear operator. So let us consider here. So from this equation, we can write max of, here the value of A is 1. So we can write here max of 1 into f1 of x comma y. So here the value is 0, 2, 2, 3. Okay. Next, plus b. So here the value of b is minus 1. And f2 of x comma y values are 6, 5, 4, 7. 6, 5, 4, 7 is equal to, here a means 1, max of f1 of x comma y. So f1 of x comma values are 0, 2, 2, 3. Okay. Plus b into, b value is here minus 1. Maximum of f2 of x comma y. So here f2 of x comma y is having values 6, 5, 4, 7. So if we simplify this, so maximum of, okay, so 0 minus 6. So the value will be, so here this is 0 minus 6. So if you do this operation, so what will be the value? So the value will become minus 6, and here 2 minus 5. So the value will become minus 3. And here 2 minus 4, the value is minus 2. And 3 minus 7, the value is 4. After performing this operation is equal to 1 into, so maximum of all these values. So in all these values, if we consider 0, 2, 2, 3, the maximum value is here 3. So let us consider 3 minus 1 into, in this case the maximum value among the 6, 5, 4, 7, the maximum value is 7. So let us consider here 7. So in this matrix, what is the maximum value? So here there is minus 6, minus 3, minus 2 and minus 4. As all these numbers are negative, so the maximum number here will be minus 2. So here the value is minus 2 is equal to 3 minus 7. So 3 minus 7 means the value is minus 4. So this is RHS and this is LHS. So in this case, RHS is not equal to LHS. So we can say that the operator H is a nonlinear operator. So this is what about the distance measures and linear and nonlinear operations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.